Oh, I love it. You know what is this? No, no idea. Well, this is a sort of charger converter. I mean, instead of dealing with all different mobile devices or any device's charger, you just connect this to the USB and power source once, and then you can charge all devices with different chargers and converters here. Easy peasy, right?
I see. Well, super useful. Now I have an idea. Let's make a solution that does the same for machine learning.
What do you mean? For
I mean, we need to figure out how we can train our machine learning model once, but we can deploy it anywhere, let's say on cloud, edge, mobile devices, web, etc., without dealing with incompatibility issues and hardware capabilities. So just having the model there in a way that is optimized to be deployed anywhere and accelerate the process.
So you mean training once, but run it anywhere on cloud or edge and etc., right?
Exactly.
Well, the solution already exists, my friend, which is called Open Neural Network Exchange, or ONNX. So I was thinking to remember. Shall we check in Azure ML and give it a try?
Then let's go.
Hello everyone, this is MG and welcome to another video which we are going to check what is ONNX, that how it can help us to optimize our machine learning solution in both training and inferencing phase in a way that we train once in your preferred framework, but then we can run in an optimized manner in any platform that we want, let's say cloud, edge, web, mobile devices, etc., without dealing with the compatibility issues or taking care about hardware capabilities that are aligned with the model that we're gonna perform, in a way that we're gonna make sure that we are making the most out of the current available capabilities we have in aspect of the platform that we're gonna deploy the model on it. Stay tuned.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, let's start with actually the official ONNX website. If you go to onnxruntime.ai, you will certainly grab great information and overall overview about this capability and all the documentations here. And then we can check it in Azure ML shortly. So, in a nutshell, what we can achieve with ONNX runtime is optimizing and accelerating your machine learning solution for both inferencing and even recently in training phase as well. So let's elaborate a little bit more on that. So with having ONNX, not only you can speed up your machine learning process, because this will optimize your models in a way that in inferencing, when you deploy the model and you're scoring your model, you can have up to even 17 times faster solution. And recently, you can even have this optimization in your training phase as well. With having that in place, you can have up to 1.4 times faster training process in your machine learning project. So not only for the optimization, this is a great solution even if you do not have it in place as of now. If you have a model already trained and you have the artifacts coming from your machine learning project, that's fine. You can still use ONNX in a way that you can convert your trained model to ONNX format that not only optimizes the speed here, but also it will be compatible to be deployed in other platforms. Let's say, as an example, you have trained your model with the goal that you want to deploy over web, and now you decide on you want to deploy the same model in other platforms, in other devices, let's say mobile phone. But somehow you need to convert that model to be compatible to be deployed in mobile phone, or at some points you might need to retrain the model with different configurations to be compatible with to be deployed on a mobile phone platform. But with having ONNX, you just train once and then you have the optimization and conversion and everything there in place for you to be deployed in a variety of different platforms and devices without making you worry about how can I make sure I'm making the most out of hardware capabilities of that mobile phone, web, or anywhere you are deploying the model, dealing with CPU, GPU capabilities, so on and so forth. So this is a great advantage in inferencing phase. And not only that, this is already a proven technology because it is vehemently being used in Microsoft services. Let's say here mention Office 365, Visual Studio, Bing. They have been all using ONNX for optimization. And in this website, I really love this interactive chart because that's the best way to start installing ONNX based on what you're doing right now. As an example, let's say if you as of now have Windows, this is the platform you're using for your machine learning project, as an example, and the API that you're using is Python. So let's select Windows, Python, and Windows 64 is what you have as of now. And let's say your hardware is just a default CPU. So how you can get ONNX for the environment that you have as of now that we have selected? Here's the answer. Pip install ONNX runtime. Let's say if you go with GPU as an example, let me actually select CUDA. There you go. This is how you get ONNX runtime if you have these configurations. So give it a try, check it out based on what you have for inferencing. If you want to get ONNX and get the benefits that I just explained, you can have this instruction here to get the answer. And the same thing for training. You can see training is a more recent feature added to ONNX. So there are a little bit limited options compared to optimization, but still you can have training. Especially for distributed training on GPU, you can have optimized training and faster training with ONNX in a way that you can install with using this instruction with the given configurations here. All right, so the question is, does ONNX only support, let's say, TensorFlow or PyTorch? If I use different frameworks to train my model, then I cannot use ONNX? The answer is you can actually. So here are the frameworks, a very quick overview of what are the frameworks are natively supported. And even if it's not natively supported, you can have converters to convert them to ONNX. We're gonna go through a hands-on example of using PyTorch, which has the native support with ONNX. You see that using PyTorch, I can just train and save my model in ONNX directly using Torch. But if it's not even supported, you can convert it. You can see here Cherry Neurocognitive Toolkit, PyTorch, MXNet, MathWork even with MATLAB, Scikit-learn, so Keras, all of them is here. And you can see some other services like Azure Custom Vision Service has native support for it. You can deploy a variety of different platforms with different hardware capabilities here. We're gonna use here Azure Machine Learning as a service to deploy, but that doesn't mean that's the only place. That's just an example. And talking about mobile phones, we made an example out of it. You can see iOS here as an example is supported, and etc. So let's go to a notebook in Azure Machine Learning that I will add the link of this notebook to the description of this video, that will check how we can train a model with PyTorch and have the outcome of, or have the save model or train model in ONNX format that we can deploy it over a web service to do the inferencing using Azure Machine Learning. So here's my Azure Machine Learning service. I am assuming that you know already this platform. I have a lot of videos created before that they all mainly use Azure ML. We already talked about the capabilities there. Make sure you check them out. Specifically the first part video of MLOps video series I created. I have a quick tour about Azure Machine Learning Service. So here's a notebook that I have already ran before recording this video. I have a compute instance running MG. This is a 4-core CPU machine with 28 GB of RAM. You can see also the cost associated with this compute instance, and I use this one to run this notebook. So I'm using this version of Python, Azure ML Python SDK, and here is just reporting some of the information about my workspace, where is the region, my resource group name, so on and so forth. You can just skip this. And by the way, you know that I'm connecting to my workspace through the config file. So when I want to interact with my Azure Machine Learning to use the capabilities in code, I just refer to this workspace or WS object here. So the first thing that I need to do is I want to train a model in a GPU machine or GPU cluster. So I need to create a GPU cluster. This is what this code is doing. I give it a name and it says create a compute cluster if that doesn't exist. So if that doesn't exist, I'm creating a GPU cluster with the maximum of number of nodes 6. So mine was already there, it didn't create, it told me that, oh, it already exists. Man, so I have a GPU cluster that I will submit my training code to this cluster to have my model trained using PyTorch. So I'm creating a folder to have my project artifacts there. And I ran this actually code, I can show you quickly. I got this folder, and what I'm training, actually I'm using the famous MNIST dataset, which is the handwritten digits, to train a neural network model to predict that handwritten digit, just as an example. And then where is my training code? That I'm copying this training code, which is mnist.py, to my folder that I have for my project, which is actually here. Let me open it. There you go. We can have a very quick overview. Again, regardless, this is just an example. That can be any training code with any framework that we already mentioned here. So here I'm using PyTorch. That I have the class of net, as you know, it's a convolutional neural network because we're dealing with images, with handwritten images, to predict the outcome. And then I'm using creating my convolutional layers, and then my linear ones, and then I'm using dropout, and of course the logSoftMax as my activation function. And then the train function, and with the given optimizer, with the loss function that I'm setting up here, with the number of epochs, actually those are the variables that are going to ship to this code when I run this, but they do have some default values. We're going to go through them. Here's a test function that I will test the train model and then print the test outcomes, and here's the main function that will be executed as soon as I run this mnist.py. You can see that these are the arguments that we need to ship to this code with their default values. For example, what is the batch size? Default is 64. The test batch size, the number of epochs, the learning rate, so on and so forth. And here's the interesting part. I'm saying here that the device that I'm training the model, if it's CUDA, there you go. If it's not there, so it is CPU. So I have the device written already in the object here. So when I have the model, I will say this is actually the device that I'm using, and then I will use optimizer for the chosen optimizer for the model that I'm training, with the given epochs that we got the number from the arguments. And here's the native support I just mentioned about. This is actually the main important thing. So I'm saving the model, but in ONNX format. So I have some dumb input. This is an example of how the model is getting the input. So then I'm saying that this is the output that I'm gonna store the model, and we're just calling torch, which is coming from PyTorch. I have .onnx.export with the extension I've added here. I have the model exported in ONNX format. And where is torch coming from? Just imported torch because I have PyTorch already installed. So going to my notebook, now I have my train code, which we went through that quickly, is stored in the folder that I want to remotely submit it to my GPU cluster I created here. So moving forward, I want to give it an experiment name. This is how you ship an experiment in Azure ML. You chose a name to later on you can track it. And then I can have the experiment defined in my Azure ML workspace that we have it here. So in Azure ML SDK, there's an estimator to make it faster when you deploy a code in PyTorch. So with importing this PyTorch estimator from Azure ML, you can see that it will ask me that, okay, give me the project folder, give me the place that you have the parameters of your script. Remember the batch size, a number of epochs, so on and so forth. The compute target, that's the GPU cluster we created, and then your script, and just tell me if it's using GPU or not. I say yes. That's it. Then I can add some more configurations. Let's say removes these packages and add some more packages, so on and so forth. So these are highly dependent on the code and the framework that you're using. So with having this estimator in place, the only thing I need is experiment.submit the estimator, which is here. And that's it. So I waited a bit to be finished. Here are the details of my run. First scroll down, and these are the files that got generated after my run. You can see that my model got generated after the run was finished, and then I was able to even download the model, and after that you can see that I got the model downloaded here, and then I have to register this model before deploying it to Azure ML, right? So with Azure ML, I say from the run that I submitted, register the model, I give it a name, and here's the path that I have the model, and that's it. I'm going to show you that this model is registered, and then this is the time that I need to deploy this model. So for deploying the model, you know that in Azure ML, you have to tell Azure ML how you're doing the scoring. This is the score.py needed for deploying your model. So I'm generating this score.py. I start with the initial function, and I'm saying that here's the model path, and here's the model. Because I'm using ONNX runtime, I have to import it. This is the optimization that I have in inferencing to make my inferencing even faster. And I put it to a session here. This is an object that I have right now. And then I'm doing some pre-processing and post-processing. Pre-processing the input data before pushing it to the model, and then post-processing to have the max confidence level label. Let's say if the model is telling 30% this picture is 3, 99% this picture is 1, then of course 1 is the answer from that handwritten picture as an input. So this is the final result, and run is the function that does everything for me. I start the timer, this is optional. This is the input data. I do some pre-processing using this function and give it, I have an input name from that input. Then for the results, I'm calling this session, which is the model actually here. I run it with the input data, and then I return the final outcome with some post-processing, and that's it. So I am ready to deploy the model. The first thing needed for deploying the model is a score.py. The second thing needed very quickly is the packages and dependencies that I need to have for deploying the model. Azure ML will need to know what are the packages needed for deploying and inferencing this model. So here are the dependencies that I want to have, and of course ONNX runtime is the main one here. And then I write these dependencies as a YAML file, because that YAML file is also needed for deploying the model. And then here's the inferencing configuration. I'm saying that for inferencing, here's the score.py I created, and here's the environment I created. Where is this environment? It is here, which is calling that YAML file we created using this code. And this YAML file contains this information. So that's the time I'm going to deploy the model with using ACI Web Service or Azure Container Instance. I say that I just need one CPU for deploying this model and 1 GB of memory. This is a tag and description. And that's it. When I deploy it, the model is now deployed as a web service. Let's check it out. First of all, we registered the model. So if I go to the model section, you see that model has been registered, that we use PyTorch. If I click on it, you can see more information about it, and this is in an ONNX format. And when I deployed the model, if I go to the endpoints, you can see the ONNX model is now deployed, and you can see it's healthy. I have the REST endpoint created by me, and it is succeeded. That was just one example of ONNX, and we talked about inferencing optimization. Now I can have a faster scoring. We talked about already dealing with incompatibility issues. When we have this ONNX format, you can deploy a variety of different devices, platforms, without having the concern of hardware capabilities or not being compatible with the platform that you're deploying your model. Check out the documentations that I went through at the beginning. There are more codes, more examples, more definitions. And if you have a model already trained but not in ONNX format, there are some code snippets to tell you how you can convert your current model to ONNX to have these benefits right there for your project. And that's it.
The only thing that you have and no one else has in the world is you. Your voice, your mind, your story, your vision. So write and draw, build and play, dance and live only as you can. See you next week.